or problem. Alright, the heat of reaction, you can tell it's that type of problem because if you look at the problem, it has to do with a chemical reaction. Okay, you got to keep this separate from a heat of solution problem. Okay, a heat of reaction problem, you always need a balanced equation. So the first thing to do would be to write the equation. So we have iron 2 oxide, so that would be Fe is plus 2, oxygen is minus 2, so FeO plus aluminum, so that's Al. Okay, and so the aluminum will go, this will be a single replacement, the aluminum will go with oxygen, but aluminum's 3 plus, oxygen's 2 minus, so it's going to be Al2O3, and then the iron will go by itself. Now, since you see that this is an exothermic reaction because it's negative, okay, the 430 kilojoules would be one of the products. Alright, now we have 2.3 grams of iron 2 oxide, excess aluminum, so we're not going to have to worry about that. The question is how much heat is produced, so that's the question. Alright, so you start off with how many grams of the iron 2 oxide you have, so 2.3 grams of FeO. You change that to moles. Okay, so we have 1 mole of FeO, and if you do the molar mass of that, it ends up being around 71.9 grams of FeO. Okay, then the next step that you need to do, and this is the new step that we are learning from this unit, is you have to do the stoichiometry. But I forgot to do one thing, and that is you have to always have a balanced chemical equation. So before we go forward, we have to balance this equation. So there's 3 irons here, and so that would be 3 over here. We have 2 aluminums here. We'll put 2 there, and so now that balances everything out. Now, here's the new step. Down here we have moles FeO here, so we have to have moles FeO here. And so you're going to get this from the balanced chemical equation. So the equation says for every 3 moles of FeO that reacts, or iron 2 oxide, you're going to get 430 kilojoules of heat energy. Now, that number could be made negative because it's going to be exothermic. That's how much heat that this reaction will produce. Alright? And so if you add all that, or multiply all that out, you end up getting around 4.6 kilojoules. The negative sign just means that the heat is going to be released from the reaction. Alright, so you could write negative 4.6 kilojoules, or you could write 4.6 kilojoules are released. Then you wouldn't need to put the negative as long as you write are released. Okay, now one thing I noticed from people on their homework and the tests and stuff is that people are goofing up where to put the stoichiometry coefficient that you need for this reaction. Okay, remember how we changed grams to moles? It's always 1 mole to so many grams. That hasn't changed. That's just the same as it was always. But the new step is you need to take the mole ratio from whatever we're starting with here, so that's FeO, so we're going to take the 3 from right here, and we're going to put that with the heat that this reaction produces here. So this is where you use the ratio from the equation. 3 moles FeO to 430 kilojoules from the equation. Alright, that's all you have to do. That's it.